Hello geometry students. Today we're learning about surface area and how to use it in practical applications. So I'm going to go ahead and write the formulas for two-dimensional and three-dimensional objects on the board, and we're going to start off with a rectangle. So for a rectangle, what you are measuring the surface area of is a flat surface. So you just have the length and the width. So the formula is pretty easy. It's length times width. Now, for a rectangular prism, you have 6 faces. So that means you're going to add the totals together of each area of the faces. So it's still the length and width, but now you have a height as well. So there's 2 faces that are length and width. There's 2 faces, which are front and back, that are length and height. And then there's 2 faces that are height and width. And so to get the surface area of the whole rectangular prism, you need to add together not only the length and width, but because there's 2 faces of each. There's 2 faces here, there's 2 faces here, and there's 2 faces here. And we're going to add all of that together to get the total surface area. Now, for our example today, we are going to be wrapping a gift and using some measurements. So I'll go ahead and show you what we're working with down here on the floor. We have our 3-dimensional object. We have our measuring tape to make our measurements with, scissors and tape to actually put the present together, and we've got our wrapping paper. So the first thing we're going to go ahead and calculate is the length and the width of the wrapping paper. So we've got, now this is going to be a fixed length because, there we go, and that is 20 inches long. So I'm going to go ahead and keep the measurements over here on the board. And for the width, we're going to use this pre-cut piece. Okay. And that width is at 11 inches. So 20 by 11 is going to be what we're using to calculate our two-dimensional area. And what we're going to try to see is if the two-dimensional area, has to be larger than our 3-dimensional area. So we've already measured this one, so now we're going to go ahead and measure the 3-dimensional object. So length, width, and height. Alright, so first is the longest side is your length, and our length, we've got that clocked in at 7.5 inches. Our width is where it's widest, and that is, technical difficulty. It is 6 inches. And our height is from here to here, how tall it stands. And that is and that is 2 inches. Okay, so now that we've got our numbers, we can go ahead and crunch them in the formula. And so what we're going to do is we're going to compare the surface areas of the 2-dimensional object and the 3-dimensional object and make an inequality with that. So now that we have our numbers, what we're going to do is we're going to create an inequality between the 2 surface areas. So for this to work, we need to have the surface area of our rectangle be larger than our surface area of the rectangular prism. So what we're going to do is we're going to say that, so for our inequality, and this is the goal, we need to have the surface area of the rectangle be greater than or equal to the surface area of the rectangular prism. Alright, and so what we're going to do is we're going to now crunch our numbers. So we've got 20 by 11, and so we'll go ahead and calculate some stuff. So we got 20 by 11. So that, oh, I mean, you can't see, sorry. Okay, so we got 20 by 11, so 11 times, sorry, 1 times 0 is 0, 1 times 2 is 2, placeholder, and then same thing. So we got 220. So we're gonna have that right here. That's gonna be 220. 220. And then I'm gonna put just a block here, and that's gonna see if that's gonna be greater than or equal to, we're gonna put that symbol in that one. Okay, and so now we're gonna crunch the numbers here. So we got 2 times 7.5 times 6. We've got 2 times 2 times 7.5, and we've got 6, or sorry, oops, my bad. Okay, got 2 times 6 times 7.5. Okay. So let's go ahead and get those calculated. So 2 to 7.5 is 15. And 15 times 6, so that's 15 times 6. So our first number is 30. That is 6, and that's 9. So 90 is our first one. So it's going to be 90 plus, alright, and that is 15. 2 times 7.5 is 15, times 2 is 30. Sorry, let me put that 15 times 2 is 30. Alright, and then 2 times 6. No, let's do 2 times, okay, and then 2 times, did I already do that back? 2 times 2 times 7.5, 2 times, okay, height, width. Height, width. I think I got that last one wrong. Height is 2. There we go. 2 times 6 times 2. So 2 times 6 is 12. And 12 times 2 is 24. So we got 90 plus 30 plus 24. Go ahead and crunch these up. So 0, 0, and 4 is 4. 9 and 3 is 12, and 2 is 4. So we got 144. So we're going to write this number over here, and that's going to be the surface area is 144. Okay, and so I will say that that is less than, so our surface area of our 3-dimensional object is 144, and our surface area of our 2-dimensional object is 220. So because it is less than, we're looking for our inequality is it to be less than or equal to, we're going to be able to use the length of wrapping paper that we have cut to wrap up the gift. And so just for all intents and purposes, the last step is that we are just going to wrap the gift. Alright, I'm gonna wrap. This goes up, it's gonna come down, and we actually have more than we need. So fold that under. One more side to go. Alright, and I will say that this is a success, that our surface areas work out. So put 2 pieces there. Alright, so I would say that our 2-dimensional object is now part of the 3-dimensional object, and that we have successfully used math to solve a real life situation. So there you have it. Thank you for watching, and remember, math makes sense.